Okay, so hopefully everyone is doing well out there. I'm going to start off, we're going to play catch up a little bit. So this is what was supposed to go on just before we left. We're going to do adding and subtracting rational expressions here. These aren't too bad. Everyone can get this. I'll try to take this slow. If you have any questions, when I post this on Classroom, you can post any questions that you have in the comments. I'll be more than happy. I'll be available. So I'll be here for you. So adding and subtracting rational expressions. So these are fractions. I know it's the dreaded F word, fractions. But things that I want to remind you guys about how fractions work. So we look at a fraction like this, and you guys do know how fractions work. You just don't realize that you know how fractions work. So if I have something like, let's say 1/2 plus 1/2. We look at this right here and just do a little physical. So we have a half plus a half, and we know that that's a whole. But a lot of you, when we're dealing with fractions, a lot of you want to add across the numerators and add across the denominator. So a lot of you want to do 1 plus 1 is 2, and 2 plus 2 is 4. And we already know physically that that is not the same. Okay, so 2/4 is not the same thing as 1 whole. So those are the mistakes that we really want to avoid with fractions, is adding the numerators and denominators. Denominators are just basically a piece of information. It just tells you what size pieces you're adding, and I'm going to show you what I mean there for just my little lesson. So let's say I have 1/4 plus 1/2. Okay, so say we have a pizza here, because pizza is always delicious, and it's 1/2 plus and then plus 1/4, because this would be a fourth. And so it's asking you, well, how much is that? Well, this is a half plus a fourth, but we really can't count that. But a lot of you, if I take this half and divide it in half, now I have 1, 2, 3/4. So I know the answer to this is 3/4. Where did the 3/4 come from? Well, this half, we actually split it into 2 pieces. So we multiply this by 2/2, and so 1/2 becomes instead plus 2/4, because we made our pieces the same size, because 1/2 of the pie is the same thing as 2/4. And so we have 1 piece plus 2 pieces. There are 3 pieces that are 4th size. So just our little basic thing on fractions, just to remind you, so you guys shouldn't be so overwhelmed. Okay, so I gave you some steps here. Number 1 says add and subtract the numerators of the expression. You need to distribute subtraction to all terms in the numerator. We'll talk about that with subsequent problems. Factor the resulting numerator or denominator completely. Divide out any common factors. So those are the 3 big key things that we're going to do if we have a common denominator. So for this first one, we notice that our denominators are the same. So we can just add across. This is going to be 13a plus 5a all over 4a squared. Now, I'm going to remind you that 13a's plus 5a's, those don't change into a squareds. Again, I'll remind you that banana plus banana is not plantain. Banana plus banana is still banana. So I add the 13a plus a 5a. I have 18a over 4a squared. So we did our adding and subtracting. Factoring, we really don't have to do much with this. So now we look at this and divide out any common factors. So for this, I look at 18 and 4. The least common multiple of 18 and 4 is 2. 2 goes into 18. 2 goes into 18, 9 times. 2 goes into 4 twice. And then we have 1a here and 2 a's here. One of these a's divides out one of these a's. So we're left with an a here. This is 1. And so I multiply across. 9 times 1 is 9. And then we have a 2a, and that is your final answer. If you kind of have the gist of this and you were good at simplifying, you can move on to the practice that's posted. But if not, I'm going to go through a few more examples, especially the subtraction, because it gets a little dicey. So for number 2, I have common denominators again, so I add across. So this is going to be y squared plus 8y plus 2y plus 21 over y squared minus 9. I look here, I have an 8y and a 2y, so I simplify. So I have y squared plus 10y plus 21 all over y squared minus 9. Now I have to look at it and I have to factor the resulting numerator and denominator completely. So I look in the numerator, and in my numerator here, I have a trinomial. In order to factor a trinomial, what we've gone through in class is we have to find two numbers. They multiply to be 1 times 21. So they multiply to be 21. And they add to be our middle term, which is 10. Now, with this, you don't have to do the split the middle method. We can actually go straight to the factored form for this. So 21 doesn't have many factors. The only factors of 21 that I can really think of are going to be 7 and 3. And 7 plus 3 is 10. So I'm going to go through and I'm going to factor this out. So for my numerator, I'm going to have, this is going to be y plus 7 times y plus 3. Remember the order in which you write it, doesn't matter. If you still want to go through and split the middle, that's fine as well. But I'm telling you, you don't have to do that. I look at my denominator. This is a binomial. We learned in a few units ago that binomials have special rules. This one right here is squared. I know it's squared and it's the difference, so it is that special case difference of squares. What you need to remember is this does actually factor onto two binomials. One is going to be plus and the other one is going to be minus. That's the reason why there's no middle term with this. Now, how do I figure out what goes here and here? I just take the square root of the numerator and I take the square root of the denominator. The square root of y squared is y. The square root of 9 is 3. So I know it's going to be y plus 3 times y minus 3. From here, now, it says divide out any common factors. I see that both of these y plus 3's are in parentheses, so they would divide out to be 1. And so my final answer is going to be y plus 7 over y minus 3. Now remember that these y's, y is not a factor. This y and this 7 are together, so you actually can't divide them out any further, and so that is your final answer. Okay. So going to the bottom here, okay, so these ones also have our common denominators. We do the same thing, geez Louise, we add across, so, or subtract across in this case. So this is 1 minus 16a squared over 12a minus 3, so that was pretty simple. Now we look at the numerator and we say, can we factor the numerator? Well, I look at this. 1 is a perfect square. 16a squared is a perfect square. So I know that this can be factored to be something plus something and something minus something. What are those somethings? Well, the square root of 1 is 1. The square root of 16a squared is 4a. And then this is going to be 1 minus 4a. In the denominator, I do the same thing that I always do, finding the greatest common factor first. With 12a and 3, greatest common factor is 3, so I divide each part by 3 here to see what's left, okay, and so I end up with 4a minus 1. Now, from the last thing that we taught with simplification, okay, I look for common factors. Now, this is 1 plus 4a, and this is 4a minus 1. Those are very different from each other. But one thing that I notice is I look for things like opposites. So what you guys have to remember, things you have to remember, because maybe they're written in a different form, is that if I have a plus b over b plus a, well, that's still going to divide out to be 1, because those are the same thing. The other thing I want you to remember is if I have a minus b over b minus a, that's actually going to be equal to negative 1. And these are called opposites, okay? Because here the a is positive, here the a is negative. If the b is negative here, then right here the b was positive. So I look and I say, okay, well, my 4a is positive here, but it's negative up here. My 1 is negative down here, but it is positive there. So these are opposites, and they do divide out, but they don't divide out to be positive 1. These two actually divide out to be negative 1, and those are the only things that I can divide out. So my final answer, we could write this two ways, is either going to be, well, I have a negative 1 times 1 plus 4a over 3. Okay, so you could see it that way. You could see it as negative 1 plus 4a over 3. But they could also distribute the negative. This could be negative 1 minus 4a over 3. Okay, but typically you'll probably see it the first two ways. All right, so number 4 is one of the tricky problems with subtraction, and we just need to remember things like those two, these are in parentheses. So again, we have our common denominators, which is lovely. So I rewrite this. So I'm going to say, all right, so I subtract across, this is going to be n squared plus 3n minus 7. Now, a lot of you are going to say this is going to be minus n plus 1. But remember that you're subtracting the whole thing. You're going to be subtracting the n and subtracting the 1. So you have two options. You can either write this in parentheses, n plus 1, and then this is going to be n squared plus n minus 6. Okay, or you can do, because you know you're going to be subtracting both parts, it's going to be n squared plus 3n minus 7 minus n minus 1 all over n squared plus n minus 6. Either way, just as long as you remember, if you want to just distribute the negative, but you always need to make sure that if this right here is subtraction, you're going to be making everything the opposite. Not necessarily negative, because if it's positive, it will become, or if it's negative, it'll become positive. So I do the same thing I've done with the previous problems, which is I combine my like terms. So I have n squared I can't do much with. I have 3n minus n, that's going to be plus 2n, and I have negative 7 minus 1, just be really careful with that. That's actually going to be negative 8 over n squared plus n minus 6. Okay, so I have a little bit of factoring to do. For my numerator, I'm looking for two numbers. They have to, let me just get a different color. Okay, when we're looking for two numbers, I know they have to multiply to be negative 8, and they have to add to be 2. 8 doesn't have that many factors. I know that if it's negative 8, they're going to be opposites. One's going to be negative and one's going to be positive. And so I think, well, 8's factors, we have 4 times 2. I know this has to be a positive 2, so the 4 has to be positive and the 2 has to be negative. So I know that this is going to factor out to be n plus 4 times n minus 2. Now, in my denominator, okay, I'm looking for two numbers. I have to multiply to be negative 6 and add to be 1. Okay, and for 6's factors, I know I have 3 times 2. This is a positive 1, so this is going to be 3 times a negative 2. So this is going to be n plus 3 times n minus 2. Okay, so I factor all of that out. My denominators divide out to be just positive 1. And so my final answer is going to be n plus 4 over n plus 3. And so that's the first part of the lesson, adding and subtracting with a common denominator.